Doing anything outside of that graphing, all of the background knowledge we have from the previous few days. Because yesterday we talked about what graphs look like in terms of their end behavior. We talked about the x-intercepts of the graph, the points that make it equal 0. And we ended talking about if the graph would bounce or go through there. So now we're really just connecting all those pieces to get an overall graph. So the steps we'll go through. On a test or a quiz, I wouldn't just say graph it and expect you to do all these steps. It would be like an A, B, C, D question. So part A, I would say find the zeros as well as their multiplicities. Part B, decide if the graph will bounce or go through at each of the zeros. Give me the end behavior. Find the y-intercept and then put all that together to graph it. So those are the things we will do on each of these problems. I don't necessarily care what order you do those steps in, so it's not like you have to have the zeros first. You could do the end behavior first or the y-intercept. Those are just all the things that we will need in order to draw the graph. So let's walk through. Can you tell me what the end behavior of this graph should be? So remember, end behavior was based off degree, right? If I multiply this out, I would have a 2x times x times x. So if I multiply it out, I get a 2x cubed. So what's my end behavior going to look like? First end is down, second one is up. If it were a negative in front, we know that would flip. The zeros. This is already factored. So to find our zeros, we really just have to set each parenthesis equal to 0. So what makes 2x minus 1 equal 0? X plus 1. Negative 1. And x plus 3? Negative 3. And that matches. It was an x to the third, so we have 3 zeros. Okay, my end behavior matches an x to the third. None of those have a multiplicity because nothing had a square or a cube or anything that went through. Then I want to know if the graph will bounce or go through at each of these. If your multiplicity is odd, the graph will go through. If it's even, it will bounce. All of these just have a multiplicity of 1, so what would happen? It goes through all of them. A lot of times I'll just write underneath and draw an arrow, or if they're all the same thing, you can just tell me it goes through all of those. Y-intercept. To find a y-intercept, we plug 0 in for x. So 2 times 0 minus 1 is negative 1. 0 plus 1 is 1. 0 plus 3 is 3. If I multiply all that, we get negative 3. That's all the information I need. Now we're drawing a sketch. I didn't find these points just for fun. All the points you find I expect to be plotted on your graph. Okay, so my zeros, those are my x-intercepts. So I hit my x-axis at 1/2, negative 1, and negative 3. My y-intercept is negative 3, so we cross the y-axis at negative 3. So now my graph has to go through all of these points. And those are the only places I can touch the x or the y-axis. My end behavior tells me it starts down. So this end starts down here. We have to come up, we cross the x-axis here, and we said it will go through all of these zeros. So it's going to go through, come back and hit the next one. Okay, still going through, so we cross the y-axis at the point we marked. Cross our x-axis at 1/2, we said it goes through, and that leaves that end pointing up, which is my end behavior. We said it would be down, up. So check at the end. The only place your graph can touch the x-axis and the y-axis are the points you marked. If you cross anywhere else, you've made a mistake. Check your end behavior. It's supposed to be down, up. That's what we have. Now, is my graph perfect? No, I didn't find other exact points. For all I know, this came way up here and dropped way down. Okay, we're just getting a rough sketch, but the things that I am checking for when I look at your graphs are, do you have your x-intercepts in the right spot, your y-intercept in the right spot, and the correct end behavior. Also keep in mind this is a polynomial. We said yesterday those are a nice smooth curve, so no zigzags. It's all curved. Okay? Any questions there? We're just going to practice this today. So let's graph this one. How is that one different than the previous problem?
It's missing x squared.
Okay.
No, that's not factored.
It's not factored. So it's a little bit harder because it's not in factored form. However, we can still do all the things we need to do. In behavior would be what? Based off the highest power, x to the fourth. Remember, even powers look like parabolas. Negatives flip it. We don't have a negative, so my end behavior is up. Okay, to get my zeros, we need this in factored form. We could do p's and q's, or, do you notice a shorter way on this one? Does anybody see how you could factor this? You would do that along with p's and q's if you want to do that. Grouping works this time. So, if you don't do grouping, will p's and q's work? Absolutely. That's why we did it in the previous section. But don't forget your old factoring techniques. Those are faster if they work. So we could take an x cubed out of this, an 8 out of this. They both have x minus 2. So my zeros, if we set those things equal to 0, if you set x minus 2 equal to 0, you just get 2. If I set x cubed plus 8 equal to 0, we have the cube root of negative 8, which is negative 2. Technically, this was x to the fourth, so we would expect 4 zeros. The others in this case are imaginary. Remember back when we factored cubics, we had the difference in some of Cube's formulas. The other zeros there were imaginary, so this is all we need. So will our graph bounce or go through at those? Remember, it's based off the multiplicity, so those multiplicities are just 1. 1 is odd, so it will go through both of them. How do we find a y-intercept? Plug in 0 for x. So you can do the original or the factored one. What do we get? All my x's are 0. So then I can draw my graph. I did give you guys a grid on this. If you didn't and you were drawing your own, you don't have to count by ones for your y-intercepts. Sometimes they're fairly big numbers, so you could count by something else here. I'm going to count by 4s. I'm going to hit my x-axis at -2 and +2. End behavior is up, up. Both ends should be pointing up. So we start up here. I have to come down and hit this. We said it would go through both my intercepts. We have to cross the y-axis down here. Come back and hit this one. We said it would go through. So it should look something like that. questions there? Let's try a few more. Oh, I did ask some other questions on this one, just making sure you can read this. What are the x-intercepts? When is p of x less than 0? So I'm asking, when is your y below 0? So that's this section. Give me the interval, so starting when x is negative, the y is negative 16 for my minimum. I really just need an interval, like what x values make this y be less than 0? Anything between negative 2 and positive 2. What makes this greater than 0? So greater than 0 is above my axis, and that happens twice. So if I'm giving the intervals for my x's, this one's coming from negative infinity and going to negative 2. This one's starting at positive. So it was above the axis before negative 2, below the axis between them, above the axis after 2. Any questions on it? Let's do this. So if I'm trying to sketch this, it's not factored. We could do our in behavior right away. It's based off our leading term. My power is odd, so it tells me it's like a chair, but the negative 2 in front would flip it, so it would be up, down. All right, to find my zeros, it has to be factored. I can't even do p's and q's here because I don't have p, I don't have a constant. What do you notice about all of these terms? Yeah, so let's go ahead, let's take out negative x. That would leave me with 2x squared plus x minus 1. What would you have to do to finish factoring that inside? Flip inside. So multiply negative 2, add positive 1, add 2 and make 1. Divide our 2 back, so we have negative x plus 1, 2x minus 1. And if you have one that doesn't factor nicely by hand, use your p's and q's to get it. So my zeros, what makes negative x equal 0? Just 0, right? What makes x plus 1 equal 0? And 2x minus 1 equals 0. All of those had a power of 1. Multiplicity of 1 means what? Through all of them. What is my y-intercept? If I plug in 0 for all of my x's, I get 0. So now we graph it. So I hit my x-axis at 0, negative 1, positive 1/2. at 0. And behavior should start up here and end down here. I draw it, starting down up here. We're going through the 0, so I'm just going to get to my point on the x-axis, go through it, hit my next one, go through, hit the next one, go through. And so my end behavior matches. Questions on that one? Just do a couple more and then I'm done. So if I ask you to graph this one, my end behavior, because it's factored, I have to think about if I multiplied it out. I would get an x squared in this one and an x to the third in that one. So altogether it would be x to the fifth. So what's my end behavior? My zeros. What makes x minus 1 equal 0? 1. Because that had a square, that's multiplicity of 2. What makes x plus 2 equal 0? Good. Okay, 1. The multiplicity was 2. 2 is even, so what will happen with my graph? Okay, negative 2, my multiplicity is 3. 3 is odd, so my graph will go 3. Even bounce, odd through. Y-intercept. You put in 0 for all of your x's. We'll get 1 times 8, which is 8. Behavior should start down here and end up here. And hit my x-axis at 1. Negative 2. Y-axis at 8. Alright, so my graph starts down here. Goes up to negative 2, and at negative 2 we said it should go through. So we go through that one. Hit your y-intercept, come down, hit your x-axis at 1, but at 1 we said it will bounce. So it's just going to touch it and come back up. So our graph looks like that. Okay? Last one. End behavior. So we have to think about if we multiplied it out, we would have an x to the fifth times an x times an x to the fourth. So altogether that would give me x to the 10. So what should that look like? Up, up. Evens look like parabolas. Zeros. Okay, we just had, this was just a plain x. What makes that equal 0? And since it was a fifth power, that means multiplicity of 5. What makes x minus 3 equal 0? 3. No power on that one, so it's just a 1. And x plus 4 would be. Alright, so at 0, will we bounce or go through? Through. The multiplicity is odd, so we go through. 3 had a multiplicity of 1. 1 is odd, so it will go through. Negative 4, multiplicity of 4. 4 is even, so it will y-intercept. If you plug in 0 for all of your x's, what do you get? Intercept is 0 times -3 times 4 to the 4th, which is just 0. All right. So I know both ends should be pointing up. Put the x-axis at 0, 3, and -4. Y-intercept is 0, so we've already got that. So I start up here. At -4, what does my graph do? Bounce. It's going to touch that, come back. We have to hit the x-axis at 0. So come back and hit there. At 0, we go through. And at 3, we go through. So it just keeps going up. So that matches what we need. All right. Any questions on this? Okay. So, I'm done. I want you to try 6 problems. The very first one, you will need P's and Q's to factor. But that should be the only one. The others are all already factored, or you can just take out something.